Alright, 3D graphics and API with graphic library, human centered CAD lab, March 31st, 2009. This is CL National University Computer Aided Design open course where we are on lecture 6, 3D graphics open graphic library. 3D graphics and API with Open Graphic Library, Human Centered CAD, 3D graphics API, Open Graphic Language Library, Interactive Computer Graphics. Example: Open Graphic Library programs, preparatory, simple code, GLUT functions, transformation matrix manipulation, other settings. 3D graphics API, Open Graphic Learning. Graphics 3D graphics modeling equal 3D graphics equal modeling plus rendering plus animation. A model is a computer representation of an object. Rendering is the process of creating an image from the model. Animation is the process generated repeated renderings of the scene. The graphics API is the application program interference with this would interface with the graphics acceleration hardware. The most popular 3D modeling technique is polygon or triangular mesh. The set of vertex polygons enter the rendering pipeline. The two best known interfaces: Open Graphic and DirectX. Open 3D graphics application program interface. Open Graphic Library. Open Graphic Library. Open Graphic Library is an acronym for Open Graphics Library. OpenGL is an acronym for Open Graphic Library. Open Graphic Library Architecture Review Board, or ARA, version 2.1, released August 2nd, 2006. Most widely adopted graphic standards: easy to use, well documented, high visual quality, performance, portable, reliable, stable, and scalable, low-level graphics command, platform independent graphics of the application program interface: Unix, Linux, Windows, NX, NT, 2000, XP, OS2, Mac, OSB, ONS, etc. This is a little dated. It's probably about 15 years old. 3D graphics application program interface, Open Graphic Library. What can we do with an Open Graphic Library? We can model primitives, draw curves and surfaces, color and shade, lights and shadow, texture mapping, fog, anti-aliasing, blending, transparency, and so many things. Interactive computer graphics program specification: 3D objects result from 2D. 3D objects result in 2D shaded images, word space, light source, the 3D object, world coordinate system, screen, viewpoint of camera. Interactive computer graphics 2, 3D objects with 2D image. We have clippings and projections, and then models, transformation, and viewport mapping. Interactive computer graphics transformation matrix, 3D coordinated transformation, 3D coordinate, 4-dimension homogeneous coordinate, rotated translation scale project represented by a 4x4 matrix, all transformation implemented, multiplying matrix sum studies in 2D where x and y is equal to x and y plus ab equaling and xy matrix is equal to xy matrix plus ab, rolling xy with a 1 and then ab xy 1, cosines and sins switching in the middle, and xy is 1 cosine sin 0 sin cosine 0 0 1, and basically we're making rectangles and triangles, translation, rotation, z-axis, scaling. So these are the basic. We have a translation to the left, your typical matrix for a rotation on the z-axis, a scaling matrix, mirror about z-plane, and then shearing. We have a homogeneous coordinates, and then we have scaling, reflection, shearing, rotation, perspective, transformation, 4x4, transformation matrix, global scaling, translation. So you're here on the left, the top right would be your translation, the perspective transformation would be on the bottom right, the far right corner is the global scaling, and then from scaling, reflection, shearing, rotation, and this 3x3 matrix on the top left hand rectangular. Interactive computer graphics, vertex transformation for each step of the Open Graphic Learning. We have original vertex that results in a model view vertex, transformed I coordinates project, matrix clip coordinates, and then perspective vision normalize the device coordinates into a view report into the window coordinates. Most geometric 4x4 matrices multiplication. Interactive computer graphics 6, lighting color of the point calculated with the material property vector positions in sight. We have ambient light, diffused light, and specular light, and then we show the diffused light and specular light. Interactive computer graphics, rasterization, lighting, scanning, converting, hitting surfaces, removal of texture, mapping, top right corner, scan version of line triangles, and beneath benefits of texture map, hitting surface, Z buffer method. Testing. Alright, interactive computer graphics 7, the rasterization, lighting, scanning, converting, hidden surface, removal of texture map. Below the texture map is the benefit of the texture map, scan conversion of line and triangle, hidden surface, remove Z buffer method. Interactive computer graphics 8, standard 3D graphic pipeline. Goes model coordinator, world coordinator, view coordinator, lighting, projection, frostcom, culling, normalize the device coordinate, review port, rasterization. Open graphic learning, Open graphic library is parallel process with geometric primitives and image data, state machine, Z buffering, Goradad shading. So we have DB transversal model transformation, trivial accept and reject, lighting, viewing transformation, position site back to viewing transformation, position site, viewing transformation, position object back to model transformation. From viewing transformation, it goes to clipping, dividing to the W by W world map and viewport rasterization to display. Preparatory. Needs for Open Graphic Learning Open Graphic Library Program, the device driver, the hardware acceleration, Open Graphic Library, NVIDIA ATI graphic card driver, the development toolkit, Microsoft Visual Studio 6.net 2003, .NET 2005, and these are outdated. Open Graphic Learning Program and Environment Header and a library. Headers.h, libraries.lib. Header files are glh, gluh, glauxh, gluth. Library files. OpenGL32 library, GL32 library, GLUT 32 library by Microsoft, and SG OpenGL library, OpenGLU library, GLUT library by SGI. Microsoft natively supports Open Graphic libraries from Windows 98 NT 4.0, but now include the GLUT graphic library UT. Preparatory Open Graphic Library command syntax about 130 functions, all functional prefix of graphic library extension graphic library translate 3F all variable the prefix graphic library underscore graphic library lighting. So we have your prefix is graphic library, your command would be the color, parameter, number of parameters, and type. These suffixes in C++ type, and Open Graphic Learning type definition. Suffix speaks and sign character. Open Graphic Library type definition is a graphic library byte. S is C++ short, graphic library short. I, suffix I, long, C++, graphic LINT, GLA, size I. F is for float, graphic library float, clamp library float, double graphic library, double clamp D. UB, unsigned character, graphic library UByte, graphic library boolean, unsigned short US, graphic library US, unsigned short. Unsigned intersection, unsigned long G, graphic library, unsigned intersection or enumerated or bit field. Preparatory Open Graphic Library related objects, Open Graphic Library utility library or GUL, prefix GUL look at, and then Open Graphic Programming Guide auxiliary library, prefix AXO, auxiliary solid box, Open Graphic Library utility kits or GLUT, prefix GLUT, graphic library, utility kit, solid cube, Mark J. Kilgore, Silicon Graphics Incorporated, high-level graphic libraries, Open Inventor, Open Graphic Library Performer, Open Graphic Library Optimizer, etc. Chunking up open graphic library code. Number included whatever you need. Main initializing a window, please. Clear graphic library, clear color orthographic beginning, vertexes, graphic libraries, and end and flush and up to date. The window end check for the events. Sample code for the graphic library auxiliary library include windows, graphic library utility, graphic library auxiliary, void my intersection void graphic library clear color void color back display graphic library color buffer bit. Graphic library 3F has X, Y, and Z's, beginning with graphic library polygon vertexes and then coordinate system graphic library and flush. Void callback reshape graphic side in matrix model load in the orthographic max model matrix model intersection intersection ARGC character RGV auxiliary display mode. Auxiliary single, auxiliary RGB position, window smoothing and shading, auxiliary reshape function, matte reshape, auxiliary main loop display and return 0. Alright, drawing objects, create vertexes, graphic library vertex 2 has 2 surfaces, 3D, 4 features, created primitives, point line, triangle, polygon. So we have graphic line strips, graphic line loop, graphic polygon, graphic line quad strips, graphic line triangle, triangular strips, graphic triangular fan. Graphic line function. Initialize existing window of the graphic library utility initiate initial ARGCP character as ARGV gluten graphic library utility initial display mode unsigned initial mode gluten initial graphic library utility initial window size initial width and initial height graphic library initial window position intersect X and Y graphic library utility destroy window initial window loading the color map void graphic library utility set color in the initial cell graphic library float red float green float blue graphic library float graphic library utility get color in initial cell into initial component void graphic library utility swap buffers void graphic library utility stroker character void front in the initial character managing background process void graphic library utility idle function void running the program void graphic utility main loop void. Alright, and then it shows initializing, drawing 3D dimension objects, handling window input objects, reshape function, keyboard function, mouse function, general transformation command, graphic library multi-matrix function, 4x4 matrix medium multiplication. The order transformation is important. Graphic library model view loaded in multi-matrix N, M, and L. Beginning graphic library beginning graphic library points, graphic library vertex 3 functions, graphic library N, transformation results, N times N times L times V, or N, M, L, V, and then show the rotating and translate, and rotate. Transformation matrix mode, model view, matrix mode, graphic library, model view, transformation object, position change, local coordinate, graphic library, matrix code mode, graphic library, model view, graphic load identity, project projection, matrix model, graphic library projection, matrix 2D, projection, define view, volume, graphic library, matrix mode, graphic library projection, graphic load identity, transformation, matrix 3, model transformation, graphic library, model view, 3 tune, model transportation, open graphic library. You have graphic library translate, graphic library rotate, and graphic library scale. So it shows translate, rotate, and scale. Viewing transformation matrix, viewing transformation graphic library model view, 2 routine viewing transformation operation graphic library translate and graphic library rotate. Initial states of viewing and model coordinates, graphic library translation. Transformation matrix, viewing transformation graphic library model view, graphic library function define viewing transformation easily, avoid graphic learning, look at double XA, double I, double E, double I, X, Y, and Z, double center X, double center Y, double center Z, double up X, double up Y, double up Z. Projection transformation, graphic library projection, viewing volume determined by view coordinators, so must call for the projection mode. Void over graphic library, double left, double right, double bottom, double top, double Z near, double Z far. Graphic library frustrum, graphic library double left, double right, double bottom, double top, graphic double Z near, double Z far. So orthographical projection by graphical library ortho, and perspective projection of graphic library frustrum. Transformation matrix 7, projection transformation graphic library projection graphic library to define view volume easily. Void graphic library perspective double void, double aspect, double Z near, double Z far. Perspective viewing from using a graphic utility perspective. Transformation matrix, viewport transform, mapping projected image within 2D window, mapping may expect distortion, different aspect ratio causes multi-viewport, distortion from the difference between aspect ratio of viewing volume and window, must change the aspect ratio of viewing volume to fit that window. Matrix manipulation, push and pop matrix. To draw civil objects, a hierarchy must save. We must save transformation matrix previous step. Assembly number A N M A to follow the NM subassembly A and M and L, and assembly N plus 1 M plus M. And you have the graphic library push matrix, multi matrix L. Draw some assembly NI. And graphic library pop matrix, matrix stack model view projection matrix, model view matrix 32 4x4 matrix, current matrix push matrix, and then to the push matrix 2 and push matrix 1, projection matrix stack, current matrix build matrix push matrix, sample coded push pop matrix. View draw wheel bolts long wheel drew wall I0 I greater than less than 5 I push rotate matrix graphic library rotate translate draw bolt graphic library pop matrix view draw void wheel bolts draw car body push matrix translate draw wheel bolts pop matrix push matrix translate draw wheel and bolts pop matrix. Other settings. The color, the red, green, blue, alpha V mode. Set red, green, blue, alpha values floating at 0.0 to tallied 1.0. Using color function example, the color is 4F, color index mode, setting index color lookup table using graphic library index function. And specify your own color table. Example, auxiliary set one color, graphically library utility tool set on color, graphic red, green, blue, alpha mode is widely used. Other settings, lighting, determine the color object final with a TD raster, graphic using graphic light function, graphic light, ambient, diffuse, and specular. Other settings, double buffering to avoid flickering. That's done by clear color, red, green, blue, and alpha to define default color of the RGBA mode. A clear index, floating index, define color mode, index mode, clear depth, clear stencil, clear accumulated, floated green, red, green, blue, alpha. Void graphic library bit field mask, initializing frame buffer, color depth buffer, stencil buffer, accumulator buffer, void graphic library drawer buffer, graphic library enumerated mode, define color mode to draw, define single buffer mode, graphic library front and double buffer back, void graphic library utility tool swap buffers, must swap buffers after draw an object double buffer mode. So you have frame 1, 10, 20, 30, 40, graphics pipeline, front, back goes, graphics pipeline, back the color buffer, and then the front with the color buffer to the screen. Graphic Library Utility Swap Buffer, Graphic Pipeline, back to the Color Buffer 1, front Color Buffer 2. Other settings, sample code using double buffering include Windows Graphics Library Utility, Graphic Auxiliary, void, my initial, void, graphic library, clear color, callback display, clear color begins, vertexes, graphic library 3Fs, end flush, and auxiliary swap buffers, view callback, reshape, graphic library size, initiation and height, matrix mode, loaded in the ortho matrix mode, graphic projection, and model view, initial main, auxiliary initial display, auxiliary double, auxiliary red, green, blue, initial position, initial window, smooth and shading, my initial auxiliary reshape function, reshape, auxiliary main loop display, return, compare with 18. Useful sites on Open Graphic Learning main manual page, www.opengraphiclearning.org, documentation specs, mains, a hard copy graphic library, HTML, Open Graphic Library Utility Toolkit, Open Graphic Library org, documentation specs, graphic library utility specs 3, Open Graphic Library FAQ troubleshooting guide, Open Graphic Library org, resources and frequent technical form tutorial and source code, neh.gamedv.net, and codeguru.com. 3D graphics application programming interference with interface with Open Graphic Library.